Start by framing the project as a practical customer segmentation problem, not just a clustering exercise. The raw data set is made of invoice lines, which are useful for accounting, but not directly useful for deciding how to talk to customers. The work in this project converts those invoice lines into customer-level RFM profiles, recency, frequency, and monetary value. From there, K-means is used to create 4 customer segments. The final goal is to support targeted marketing tests, not to claim that the model already changed business outcomes. The most important numbers are on this slide. The raw UCI file contains 541,909 transaction rows. After cleaning and aggregation, the actual modeling table has 4,338 customer-level RFM records. That shift matters because the unit of analysis changes from a sale line to a customer. The model also starts intentionally narrow. It uses only recency, frequency, and monetary value because those are easy to explain and directly tied to buying behavior. More complex features could be added later, but the first pass should be auditable. The business problem is inefficient targeting. A retailer may know what was bought, when it was bought, and how much it cost. But that does not automatically tell the business which customers should receive which message. A broad campaign treats loyal repeat buyers, occasional high-spend customers, and inactive customers the same way. That is the gap this project addresses. The analysis does not cluster invoice rows because that would answer the wrong question. Instead, it builds one behavior profile per customer and then clusters those profiles. This slide is the proof of work slide for data preparation. The raw file starts with 541,909 transaction rows. The largest drop happens when rows without customer ID are removed. Those rows may still represent real sales, but they cannot be assigned to a customer segment because there is no customer key. Canceled invoices are removed next, followed by rows with invalid quantity or price values. After those filters, the remaining transaction rows are aggregated into 4,338 customer records. That final customer table is what the clustering model actually uses. This slide explains how the modeling table is built. Recency is calculated from the reference date, using the customer's most recent invoice date. Frequency is the count of unique invoices per customer, not the number of product lines. That distinction is important because a customer with one large basket could otherwise look like a frequent buyer. Monetary value is the sum of quantity times unit price by customer. After these features are built, StandardScaler is applied before K-means, so the distance calculation is not dominated by spending. This slide explains why 4 clusters were selected. The model tested K values from 2 through 7. Inertia drops as K increases, but that alone is not enough because adding more clusters almost always lowers within cluster variation. The silhouette score helps check whether clusters are separated, and the table makes the comparison explicit. Within the tested range, the 4-cluster solution gives the best balance of silhouette score, interpretability, and business usefulness. It avoids too few segments while also avoiding small artificial groups that would be hard to act. The final model produces 4 customer segments from the 4,338 RFM records. The regular buyer segment is the largest group. That makes it important operationally because even small improvements in average order value or repeat purchase rate could matter. The high value repeat segment is much smaller, but it has the strongest customer value and should be protected carefully. The segment names were assigned after reviewing the RFM averages. K-means gives numeric cluster IDs. The business labels come from interpreting the profile. This slide is where the behavioral meaning becomes clearer. Recency is inverted into recency score for visualization because raw recency can be confusing. Normally, a higher recency value means the customer bought longer ago, which is worse. In this chart, higher is better across all 3 metrics. More recent activity, more invoices, and higher spend. That makes the high value repeat segment stand out clearly. It also shows why the occasional high spend segment should not be dismissed just because frequency is lower. Low frequency does not always mean low value. This is a business slide. The point is not simply to name segments. It is to decide what to test. High-value repeat customers should not automatically receive broad discounts because they are already active. A better first test is loyalty recognition, early access, or recommendations. Regular buyers are the cleanest growth opportunity, so a bundle offer versus recommendation email versus holdout test would make sense. Occasional high-spend customers need different handling because lower frequency does not mean low value. Inactive customers should receive low-cost reactivation first so the business does not spend heavily on customers who may not respond. The ethical section keeps the recommendations grounded. Customer ID is used only as a grouping key, not as a model feature. The segments describe behavior patterns, not customer identities or personalities. There are also practical limitations. The data covers about 1 year from a UK online gift retailer, and canceled invoices are removed rather than modeled as return behavior. RFM features are useful but narrow. They do not include product preferences, discounts, marketing exposure, or seasonality. The next step is testing segment-level actions before claiming operational impact. Close by, returning to the main story. The project starts with raw transactions, cleans them, builds customer-level RFM features, tests cluster counts, selects 4 interpretable segments, and converts those segments into testable marketing actions. The strongest Q&A points are the unit of analysis change, the use of unique invoices for frequency, The K equals 4 model selection logic, and the limits of unsupervised segmentation. The model is useful because it organizes customer behavior, but its business value should be proven through experiments.